Hello everyone, welcome to the course Structure Analysis. I am Dr.S.Pachaiappan, Assistant Professor, Department of Civil Engineering, Aditya University. So today we are at 28th lecture. So last lecture we are discussed about the analysis of two-hinged arches subjected to UDL throughout the span, and also how to calculate the reaction force of the arch when the UDL is acting only portion of the arch. So in today's lecture, we are going to analyze the two-hinged arches only, but it is subjected to point load at the center. So at the end of the lecture, student can able to understand and then analyze a two-hinged arch subjected to point load at the center. So whatever the diagram we are seeing here is a two-hinged arch. So there is a hinge located in the point A. And then the point B, let's mark this is support A and then this is support B. So in these two locations, hinge support is there, and we can able to see the point load at the center. W is acting downward direction, and then the distance between the bottom of the arch from that crown is called as capital H, which is small h, that is the height of the arch, and then capital H is the horizontal thrust, which is we are going to calculate it now. So since the load is located symmetrically, you can able to see right hand portion and left hand portion both are looking similar, and the load is acting exactly at the crown. So this is the load symmetrically loaded truss. Symmetrically loaded arch member. Okay. Now you see, because of that, the VA is equal to VB. The vertical reaction at support A and vertical reaction at support B is nothing but a W by 2. So the total load is equal to capital W. Two supports are there. That's why divided by 2 will be getting the reaction force W by 2. So here the reaction force acting is W by 2. And here also the reaction force which is acting is a W by 2. Now what we have to do, we need to consider two sections. One is the left side of the load, another one is the right side of the load, and then adding both, and then we are going to integrate it. So this is the formula for the horizontal thrust. Earlier lectures also we are discussed. Integral over m naught y dx divided by integral y square dx. So what we have done, first we are going to consider the section 1-1. So this section 1-1 is located x distance from the left support. So what our intention is to calculate is, we are going to calculate the integral over m naught y dx, which is splitted into the two boundary conditions. One is 0 to L by 2, another one is 0 to L by 2. Sir, you may ask that, sir, if it is a 0 to L by 2, then the next boundary condition to L by 2 to L. Yeah, whatever your doubt is, that is correct only. But since it is a symmetrical section, if you consider 0 to L by 2 and then once again 0 to L by 2 also, nothing wrong in that. Now, so integral 0 to L by 2, this m naught y1 dx plus integral 0 to L by 2 m naught to y2 dx. So since two times it is coming, two sections are there. So I am writing that 2 times of integral over L by 2 integral over L by 2 m naught y1 and dx. Okay. So we have 2 times, this is 1 time, and then this is second time, the same equation, so it's multiplied. Then you might ask, sir, here the y1 is there and here the y2 is there, here m2 is there, how both are same? The both are same because of the symmetrical loading condition. Now calculate m naught from the point A. So m naught means what? It is a moment which is force multiplied by the perpendicular distance. So here the force is our RA multiplied by, with this distance is up to the XX section is X. That's why we are getting the m naught one is W by 2 into X. Now this is the equation of the parabola. Y is equal to 4hx into L minus x by L square. So we have this equation already from the previous slide. What is that? 2 times of integral 0 to L by 2 m naught y1 dx. Okay, now we are going to substitute the terms of this m2 and then y1 bar, y1. So m2 you already know, which is you can able to see m2 is w by 2 multiplied by x, and then y we are having here, which is 4hx into L minus x by L square. So multiplying these two, and then I am taking some common terminologies outside. What are that common terms? 4 times of WH and then L square I am taking outside. So this 4 is out of the integral, it's not the function of integration, that's why we are taking outside. 4H and then this L square was taken outside. Then what is the remaining term will be there? We are going to have L into x into L minus x. We are going to have the remaining term x into L minus x. Okay, so this is only written here, and if we can able to multiply this also inside. So if you multiply, we are going to get Lx into x square. Okay, but if you see, so 2 times of we have written, and then so from that we are getting L into x square minus x cube. So here we can able to see, here 2x is there actually. So this is the first x and this is the second x. So x into x, x square multiplied by L, L x square, and then x square multiplied by x is x cube. Okay, got it. Now it's 4wh by L square. Now I am going to do the integration. Let's substitute the upper limit minus lower limit. So the upper limit is L by 2. Instead of x I am substituting L by 2. Because of that I got the x cube by 3. So in place of x square I am going to substitute L by 2. So if I substitute L by 2, we'll be getting Lx cube by 3. Then in the place of x, actually we are doing an integration here. So L into x square minus x cube. So integration, what it will become? L into x cube by 3. So this will become x power 4 by 4. So far we never applied the upper limit minus lower limit, just we are integrated. After that only we need to substitute the limits. So here the limits are substituted, that is the limits are L by 2 and then 0. So after substituting the limit, you see L into L cube become L power 4, and then here we are having L power 4, and simplifying upon this I will be getting 5L power 4 divided by 192. Finally we got what is integral over m naught y dx is nothing but 5wh L square by 48. Now we need to find out the value of integral y square dx. So we have the y equation, we are going to put the square term to that. So after putting the square term, I am taking the common terminologies are outside. What is the common terminologies here? 4h and then L square are commonly taken out. So 4 square is 16, h square is became h square, and then already we have a L square inside, which is become L power 4 here. So we have a remaining term x square into L minus x the whole square dx. So this is the formula we are applied here. What is that? A square plus b square minus 2ab. So this is a minus b the whole square formula. So that's what we put, a square plus b square minus 2 times of ab. That's what we have substituted here. So after that, just take this x square inside, just multiplying with the individual components, will be getting Lx square plus x power 4 minus 2Lx cube. Okay, just I multiplied inside. Now I am going to do the integration with respect to x. So here x square is there. During the integration it will become x cube by 3. And then x power 4. So here x power 4 is there, and then the integration of that is written here. So x power 4 became x power 5 divided by 5, and then this term is written here. What we are going to have? Minus of 2 lx power 4 divided by 4. Okay. So then 16h square divided by L power 4. Then just simplifying this, you see here and substituting the upper limit minus lower limit. So upper limit is L square. So L square multiplied by L cube. It will become L power 5. That is written in the next slide. Now this is L multiplied by L power 4, also L power 5. And x power 5 will become L power 5. You can able to see it here. So I am just cancelling this 2 and 4, will be getting 1 by 2. So in this equation we can clearly able to see everything in terms of L power 5. So simplifying upon this, I will be getting L power 5 by 30. So here L power 4 is there in the denominator. Cancelling these two, I will be getting L. So the integral 0 to L y square dx is nothing but 8L h square by 15. So this is our final equation. So by component we calculated integral m naught y dx, and then we are calculated integral y square dx. Putting both the values and substituting in the formula, and then I'm just reversing this value for cancelling, just reversed. So then I'm cancelling this L and L will be get cancelled, so remaining we have 1 L, and then this h and h will be get cancelled. So here h square is there, we have a remaining h. So upon simplifying this by using the calculator, you will be getting 25 divided by 128 into WL by H. So this is the horizontal thrust of the two-hinged arch when it is subjected to point load at the center. So in the examination, if they ask that a point load is some numerical values, it's very simple. Directly you can able to substitute this formula and then get the horizontal thrust. If it is a derivation, you need to all the way derive how I derived in this PPT. So at the summary, what we are learned? We have learned how to calculate the horizontal thrust of a two-hinged arch subjected to point load at the center. So in next lecture, we will see the another case, and then slowly we will be moving to the three-hinged arches, and then flexibility matrix, and then stiffness matrix, so that this course will be over. So probably it will take 7 to 10 lectures to complete the entire course. So thank you for watching this lecture. Thank you.